Hi Precalc students. I am out sick today, but I'm going to give you a lesson on this short video, and then I've gone ahead and set up the modules on Alex, the required one and then the optional one, or there's bookwork. So pick one or the other to do. Either do the bookwork and check your odd answers on the Calc Chat Larson website, the Calc Chat button, or do the optional Alex problems. Do not just do the minimal problems or you're going to struggle. You won't have enough practice. All right, section 2.3. Sorry about the scan. It's my home scanner. It's not quite as good as the school scanner. But 2.3 is solving trig equations. So now we're looking at equations with trig expressions in there. And of course the idea is just to use inverse operations to get your variable alone or find what your x value is. And your goal is to first get the trig expression alone. So we're going to go through, I think, 5 different examples. Number 1, and you will see the questions ask you for solutions in a certain interval, 0 to 2 pi usually, or they will ask you for all solutions. So we're going to go through both types on this first one. So our first example is 2 sine of theta plus square root of 2 equals 0. Your first step is to get sine of theta alone. So we subtract square root of 2, we divide by 2, we have sine of theta equals negative square root over 2. Now, where is that true? We're looking on the interval 0 to 2 pi. So looking from 0 to 2 pi, I know that sine is negative square root of 2 over 2 at 5 pi over 4 and over here at 7 pi over 4. So those are my two answers that would fall between the interval 0 and 2 pi. Other questions will ask you to find all solutions because we know that there's an infinite amount of angles that have sine of negative square root of 2 over 2. And to find those other angles, we simply take 5 pi over 4 and add any multiple of 2 pi. So we're going to add 2k pi where k is an integer. And the other infinite set of solutions is 7 pi over 4, right here in quadrant 4, plus all multiples of 2 pi, 2k pi. And then define k to be an element of integers. And integers is this big Z. It has this double middle bar. So 2 sorts of solutions should be asked for on Alex or in the book within the certain interval, 0 to 2 pi, and then all solutions. And that's when you add your multiples of 2 pi, at least for sine and cosine. Number 2, here's a square function. Cotangent squared theta minus 1 equals 0. We simply add 1 to both sides and get cotangent squared theta equals 1. And we take the square root of both sides, so we have cotangent of theta equals positive or negative 1. That should be a negative. And then again, you're just looking on your unit circle for when cotangent is positive or negative 1. It is positive 1 at pi over 4 and 5 pi over 4. And it is negative 1 at 3 pi over 4 and 7 pi over 4. But if we look at all solutions, we can consider all solutions at every pi over 4 plus any odd number pi over 4. So 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Those will all work right there. Next up, number 3. Here is a quadratic. We have a cosecant squared, a cosecant to the first power, and so our function 2 cosecant squared x minus 3 cosecant x minus 2 equals 0 is a simple quadratic that we want to factor. If it confuses you to factor with the cosecants in it, factor it with just the x's in it and then replace with cosecant. This factors to 2 cosecant x plus 1 cosecant x minus 2 because 2 cosecant x times cosecant x is 2 cosecant x squared. We've got 2 cosecant x times negative 2, cosecant x times 1. So that gives us negative 4 plus 1, which is negative 3 cosecant x, and 1 times negative 2 is negative 2. Now set each of these values equal to 0, like you would a regular quadratic. So we have 2 cosecant equals negative 1 when I set them equal to 0 and then solve for cosecant x. I divide by 2, and now I'm looking for when cosecant is negative 1/2. Well, we know that's never true because cosecant's range goes from 1 to infinity, so there's no values that make this true. So I look at the other part, the other factor, cosecant x minus 2 equals 0. I add 2 to the right side, and I know cosecant is 2 at pi over 6 or 5 pi over 6. Remember, cosecant is 1 over sine, so we're looking for the angles where sine is equal to 1/2, because 1 over 1/2 gives us the 2. And so our final answers are pi over 6 and 5 pi over 6. Number 4 is another example, and when solving these trig equations, you can use your identities to simplify things. For example, negative sine x equals negative cosine squared x minus 1. Well, we've got a cosine and a sine. It would really help us out if everything was in the same trig function, so we could get that alone. So I'm replacing cosine squared x with 1 minus sine squared x. And I have then negative sine x equals negative 1 plus sine squared x minus 1. I'm going to move this sine over to this side, and so I have sine squared x plus sine of x minus 2 equals 0. Now that everything is in terms of strictly sine, I can factor, it's a quadratic, to sine x plus 2, sine x minus 1. And I set each factor equal to 0. I have sine of x equal negative 2. This never happens because remember, sine wavers between negative 1 and 1. And I have sine of x equals 1, and that happens at pi over 2. So my answer between 0 and 2 pi is at pi over 2. And my last example here is a little bit longer. It is 2 cosine 2x over 3 minus square root of 2 equals 0. Now note this one's a little different because after the cosine I don't just have an x, I have 2x over 3. So in this example we're going to look at how to address that. So I first add my square root of 2 and divide by 2. So I have cosine of 2x over 3 equals square root of 2 over 2. So I want to find where cosine is square root of 2 over 2. Well, that happens at pi over 4, and at 7 pi over 4 for my solutions 0 to 2 pi. If I'm looking at general solutions, meaning any angle that will work, well, even angles smaller than 0 and bigger than 2 pi, I do pi over 4 plus 2k pi, and 7 pi over 4 plus 2k pi, meaning plus any multiples of 2 pi. Now what we're going to do is going to consider our 2x over 3, because this is just where the cosine is square root of 2 over 2. So now I take these general solutions, pi over 4 plus 2k pi, set it equal to my 2x over 3, and I take the other general solution, 7 pi over 4 plus 2k pi, and set it equal to 2x over 3. And I'm going to solve each one for x. So from both sides I multiply through by 3 to get rid of 3 in the denominator, and I divide through by 2. So on the left side I have 3 pi over 8 plus 3k pi. On the right side I have 21 pi over 8 plus 3k pi. Now we want to find the values between 0 and 2 pi. So remember, k can be any integer, and we're going to start with the smallest integer. We're going to start with 0. We're going to substitute 0 in for k. So I have 3 pi over 8 plus 0 pi, which is 3 pi over 8, which falls between 0 and 2 pi, so I know 3 pi over 8 will be a solution. My next possible option would be if I use the next angle up, which would be adding 3 pi. But notice if I add 3 pi, I'm already larger than 2 pi, so this angle will not work within my 0 to 2 pi range. Likewise, on the right side, I have x equals 21 pi over 8. I'm going to set my k equal to my first integer 0, and I get an answer of 21 pi over 8. 21 pi over 8 is already larger than 2 pi, so there is not an angle between 0 and 2 pi that meets these conditions. So in this area, there's no solution. So the only solution that works here is 3 pi over 8. All right, hopefully that will give you a good set of examples to look through as you try your problems. I have the first module set up on Alex. You can start trying there. I think it has 10 skills. And so try your hand on those. Some of the simpler equations are in the optional module. So you might want to look at, try the required modules and then try the optional modules. You're always welcome to look at the homework, the odd numbers in the book, and they're also available on the Larson website in case you don't have the book. For the Larson website, let me show you where to go. So if you click on Larson Precalculus, click on Calc Chat, we are on Chapter 2, Section 3, hit Go. And you can start scrolling through the questions. 5, 7. It gives a lot of examples. You don't have to do every one, but do a few from each section. Scroll through them. If it looks like something you know how to do that's easy, that's fine. If not, give it a try and compare your worked out solutions with those here that are available on the website. If you have any questions, email me. I will see you Thursday.